Okay, hi, this is Chapter 6 of Routing and Switching Essentials. So we're going to talk about VLANs. So we're going to look at VLAN segmentation. So why do we do VLANs? And see how VLANs affect our switches forward frames. We'll look at VLAN implementations, and so we'll look at how to configure a switch port to be assigned to a VLAN. We'll configure trunk ports, and we'll look at troubleshooting VLAN trunk configurations. And we'll also look at inter-VLAN routing. So of course, new VLANs means new subnets, which means new router interfaces, and there's ways to do that. And so there's legacy or router on a stick inter-VLAN routing, basically. So VLAN segmentation. So VLANs can segment LAN devices without regard for the physical location of the user or device. In the figure, IT users on the first, second and third floors are all on the same LAN segment. The same is true for HR and sales users. And so basically we've got three groups of users. The switches are actually supporting all three of these particular VLANs. And so a VLAN is a logical partition of a layer 2 network, and so multiple partitions can be created and multiple VLANs can coexist. The partitioning of the layer 2 network takes place inside the layer 2 device, usually via a switch. Each VLAN is a broadcast domain that can span multiple physical LAN segments. Hosts on the same VLAN are unaware of the VLAN's existence, and so VLANs are mutually isolated and packets only pass between VLANs via a router. And so the hosts in VLAN 2 cannot talk directly to the hosts in VLAN 3 or 4 and vice versa. They need to go via the router to get their packets between them. And so what are the benefits? And so it can improve security, it can reduce costs, it can have better performance, smaller broadcast domains, IT efficiency, management efficiency, simpler project and application management. So basically the improved security is you can have less hosts on the same subnet, and so there's so many ways that that's more secure. But also when it comes to reduced cost, you can actually implement these extra subnets and the like without actually having to buy extra hardware, because you can do it all on the same switch, and so it can be much more efficient than having a switch for each different subnet. And so you might end up having lots of extra switches with unused ports, because some of the VLANs just aren't big enough to warrant it. And so it can be and so smaller broadcast domains, if you've got less hosts, there's going to be less broadcasts, and so it means that the bandwidth is used more efficiently. And so there's many benefits to the VLANs. Okay, so there are common types of VLANs, and so there's a default VLAN. So when you have a Cisco switch straight out of the box, this is how it will look. There will be one VLAN in use. It's VLAN 1. It's the default VLAN, and every port is a member of that VLAN. And so basically, if everyone's in the same VLAN, everyone can talk to one another, and it's, again, completely transparent. Don't need to know. And so, of course, there are data VLANs, which are basically a default VLAN is a data VLAN, but there are extra ones you can create. So then you can create VLAN 2, 3, 4, 10, 20, 50, whatever it might be. Now, a native VLAN is actually one that does not have tagging, which we'll talk about a bit later, and it carries this traffic that does not originate from a VLAN. And so basically a whole pile of the housekeeping that's done between switches, that traffic goes on the native VLAN. So again, by default, it's VLAN 1, but of course, that's because it's the only VLAN created. You can change the native VLAN. And so we really talk about native VLANs being over trunk links, typically, but yeah. And so a management VLAN is that VLAN that you create. So actually the previous chapter was when you create that switch VLAN interface, switch virtual interface, sorry. And so then you can actually then configure remote management. So that's your management VLAN. So these three types of things should actually all be separate, just so you can secure them better. But when you look at the labs, often the native VLAN and the management VLAN will be the same. That's not bad, but it's not best practice. And so, yeah, they're the major types of VLANs. And of course, there is another one that's a voice VLAN for VoIP. Okay, which is this slide. To support time-sensitive voice traffic, Cisco switches support a voice VLAN that requires assured bandwidth, a delay of less than 150 milliseconds, transmission priority over the other types of traffic, and ability to be routed around congested areas on a network. So the voice VLAN feature enables access ports that carry user data and voice traffic at the same time. And so if you've ever seen hardware VoIP phones, you plug the phone into the switch, and then you can actually plug the host into the phone. And so basically you'll have whatever the traffic, the data VLAN is on this port, as well as the VoIP VLAN, which apparently is VLAN 150. And so that 150, the voice VLAN will only go as far as the phone. The PC will never see it, but the phone will pass on the data traffic to the PC. Okay, so VLAN trunks. And so a VLAN trunk is a point-to-point link that carries the traffic of more than one VLAN. And so usually established between switches to support an intra-VLAN communication. A VLAN trunk or trunk ports are not associated with any one VLAN. They actually carry the traffic of some, most, or all VLANs. Now, for the traffic to go across a trunk link, that's when I think I mentioned quickly the term tagging before. They actually have to put an extra field in the Ethernet header, and typically standards-based at least is 802.1q, and that will actually have the VLAN ID in the header. And so the switch that sends it on the trunk link will put the header on, and of course the one that receives it will interpret the header. And so the links between switches 1 and 2 and 1 and 3 are configured to transmit traffic coming from VLANs 10, 20, 30, and 99 across the network. And so if they're the VLANs that are being created, they're the VLANs that will actually go over these trunk links. If you didn't have trunk links, you'd actually have to have a link between each switch for every VLAN, and that's not very efficient for switch ports. So a way to control broadcast domains is by creating VLANs. And so if a switch port receives a broadcast frame, it forwards it out all ports except the originating port. Eventually, the entire network receives the broadcast because the network is a one broadcast domain. With VLANs, traffic will not go from one VLAN to another, and so that broadcast will not see every host. It will only see the hosts on the same VLAN. And so VLANs can be used to help control the reach of broadcast frames and their impact on the network. Because you don't have to buy extra hardware to create these extra VLANs, you can have smaller subnets and there will be less broadcasts anyway. And so there are several ways that VLANs improve broadcast wastage of resources. Sorry. In the figure, PC1 on VLAN 10 sends a broadcast frame. There's PC1 on VLAN 10. The trunk links between switch 2 and switch 1, and the trunk links between switch 1 and switch 3 will propagate that broadcast, but only other hosts on VLAN 10 will see it. So that student and that student 1 will not see it, but this faculty host here, PC4, will see the broadcast because they're on the same subnet and VLAN. So tagging Ethernet frames, as I said, there's the 802.1q. Before a frame is forwarded across a trunk link, it must be tagged with its VLAN information. Frame tagging is a process of adding VLAN identification header into the frame. It's used to properly transmit multiple VLAN frames through a trunk link, and they, of course, remain on that VLAN when they get the other end. And so 802.1q is very popular VLAN trunking protocol that defines the structure of tagging header added to the frame. Switches add VLAN tagging information after the source MAC address field. The fields in the 802.1q VLAN tag includes VLAN ID, and that's the one we care about. And so the trunk links add the tag information before sending the frame and then remove the tags before forwarding frames through non-trunk ports. Okay, so native VLANs and 802.1q tagging. Control traffic sent on the native VLAN should not be tagged. Frames received untagged remain untagged and are placed in the native VLAN when forwarded. If there are no ports associated to the native VLAN and no other trunk links on an untagged frame is dropped. When configuring a switch port, on a Cisco switch, you configure devices so they do not send tagged frames on the native VLAN. In Cisco switches, the native VLAN is 1 by default, but as I said, you can change that. So voice VLAN tagging, an access port connecting a Cisco IP phone can be configured to use 2 separate VLANs, one for voice, one for data. I did say this before. So the link between the switch and the IP phone behaves like a trunk link, but only carries the traffic of 2 VLANs. Those 2 VLANs that were just mentioned. So the Cisco IP phone contains an integrated 3-port 10100 switch dedicated for those devices. Port 1 connects to the switch, port 2 is for the IP phone itself, and port 3 forwards it to the PC. And so this here is a trunk link. The voice traffic, of course, goes there, and then the data traffic goes to the PC. And so that's all so that, well, basically they wanted to enable it so that you could add voice phones without having to put in extra data cables. And so that was the whole idea behind it all. They wanted to make it easier for you, so you're more likely to buy their equipment, I suppose. And so that's why they did it. So how do we implement VLANs? Now, Cisco invented VLANs back in the dark ages, as in last century, and they had their own system for it, and they had their own sort of rules. And what Cisco calls normal range VLANs are ones that conform with their original standard. And so you basically had VLANs numbered between 1 and 1005. As you can see, by default, you've got VLAN 1, and these other ones are here. They are also default ones. As you can see, they all say default. They're for special purposes. You'll rarely ever use them because we don't do token ring and FDDI very often these days. And so, but they're there still. And so, basically, the ones that conform are normal range to the old rules, basically. And then, of course, they brought out 802.1q, which is a standardized based version of it all. And you can have up to 4096 VLANs. And so Cisco calls them extended range VLANs. And so they do support it. They are standards compliant, but it just treats them a little differently, that's all. So when you configure normal range VLANs, it actually creates a VLAN.dat file and stores all the configuration information there for the VLANs. If you do extended range, it actually puts them in the config file. Now VTP, which is something we'll look at in CCNA 3, does not support extended VLANs anyway. So Cisco Catalyst 2960 and 3560 switches support over 4,000 VLANs. 4,096 to be precise. Okay, so how do we create a VLAN? So, of course, you need to go into global config mode, then you type in VLAN and a number. So you've got the example here, VLAN 20. And so once you've done that, the VLAN is created. You're also in VLAN config mode, and so you can actually give it a name, a descriptive name. And so in this case, we're calling that VLAN the student VLAN. And so basically, the VLAN is created. It's not on any ports yet. And so that's the next thing you need to do, is go into whichever port needs to be a member of that VLAN 20 that we were looking at earlier. And so you'd put it in a switch port mode access, and so that means there's going to be a host connecting to this port, and then you do switch port access VLAN 20, as it does here. And now port 18 here is a member of VLAN 20. And that's it. That's the most things you need to do. So here, of course, they're actually showing how you would do it for a phone. And so we've created VLAN 20, it's student, VLAN 150, they've called it voice, which is a pretty good name, I suppose. And then you go into port 18, switch port mode access, switch port access VLAN 20, again, identical to the previous one, but then you can actually do, you've got basically some quality of service setting there, and then you do switch port voice VLAN 150. And so that will turn that into a trunk port, so your VoIP phone can use it. And so you just have to tell the VoIP phone that it's VLAN 150 for itself and VLAN 20 for the host, and away you're off. Okay, now to put it back to VLAN 1. So did we actually have a show VLAN in any of those slides? No, we didn't. Okay. So show VLAN when you create VLAN 20. That's how it looks. But here, that's actually taking this port out of VLAN 20, so that's why 18 is back in this list here. If you'd actually had switch port access VLAN 18, you would have had 18 not listed here, and 18 would have been listed on this line here. So to delete the entire VLAN, you can just do delete flash VLAN.dat. That's actually one of the steps you need to do to return the switch back to default. Is you can do array startup config and delete flash VLAN.dat, and that's actually how you return the switch back to default. So an extra step for a switch, basically. You can do no VLAN 20 to get rid of it, of course. But yeah, if you want to get rid of all of them and take it back to the default, it's probably quicker and easier just to delete the VLAN of that file. You normally have to reboot with that though. VLAN configurations can be validated using show VLAN and show interfaces command. And so show VLAN, of course, they're doing show VLAN student, so it's just showing you what's happening for VLAN 20 here, so you can see the ports 11 and 18 are members of it. And down here, show interfaces VLAN 20 shows you that VLAN 20 is up. Line protocol is down, what might mean there's no ports actually using it. Now trunk links. So basically, as we said, a trunk link would be a link between two switches so that you can move the traffic of multiple VLANs across it. Also, it can be a port, a link between a switch and a router if you're doing the VLAN routing, which we'll talk about later in this slideshow. And so to turn it into a trunk port, all you have to do is the command switch port mode trunk. That's all you need to do. Now these extra commands can sort of change the way it behaves. And so remember we were saying that the native VLAN is VLAN 1 by default. Well, here we're changing it to VLAN 99. And so that's the untagged VLAN. That's what native means. And so that's fine. Of course, you need to have a VLAN 99 first. You can also specify which VLANs are allowed across a particular trunk link. And so, of course, we've created these 4 VLANs, and so we're permitting them all. If you don't do this command, all VLANs will be allowed across it. So you don't necessarily need to do that. That's only on specific circumstances you really need to do that. Now with a native VLAN, if you do it on one end of the trunk link, you need to do it on the other as well. And so if you do it on one end but not the other, you'll actually get errors of native VLAN mismatch, and the trunk link will not work. And so you need to do it on both ends. And so you can, of course, get rid of those configurations. So no switch port trunk and no switch port loud VLAN and then native VLAN. And so you can put them back to default. Oh, wrong key. And so you can verify trunk configuration by basically show interfaces, and it'll tell you that its administrative mode is trunk, it's operating as a trunk, and it's using .1Q encapsulation, what the native VLAN is, and so on. Now, what problems can we have? So, of course, hosts on a VLAN all need to be members of the same subnet. Sorry. And so basically a VLAN and a subnet are an interchangeable sort of thing. They relate to one another directly. And so if you've got hosts on VLAN 10, all of those hosts need to have the same, have address from the same subnet. And so we've got 172.10.21, we've got 172.17. So I'm assuming we've got an addressing issue there somewhere. And so that's why they can't talk. So basically addressing is the same. If they're all on the same VLAN, then it need to all be on the same subnet. Of course, if you haven't configured all the VLANs and all the switches, you're going to have problems. And so the trunk links won't work with VLANs that a switch doesn't know about. And so that's something else you need to do. And of course, the trunk links, you need to make sure that both ends of the cable are configured to be trunk and that they have matching native VLANs. So problems with trunks, as I said, native VLAN mismatches, trunk mode mismatches, and allowed VLANs on trunks mismatched as well. And so that allowed VLANs command needs to match on both ends for it to be a happy trunk. Okay, so port modes. In this example, PC4 cannot reach the web server. So PC4, where's that? That's here. So it's got to go from switch 3 to switch 1 to get to the web server. And trunk links on S1 and S3 are verified and reveal that the S3 trunk port has been configured as an access port. So if you configure it as switch port mode access, it will not be a trunk port. It's expecting a host on the other end of the cable. And so it will not talk. And so that's a bad thing. So incorrect VLAN list, so show interface as trunk. And so again, the allowed VLANs are wrong. Okay, so Inter-VLAN routing. I think this is the last topic for this chapter. And so layer 2 switches cannot forward traffic between VLANs without assistance from a router. Inter-VLAN routing is a process of forwarding traffic from one VLAN to another using a router. And so the three major options are legacy inter-VLAN routing. So basically that's what this is a port on a router per VLAN. And that does work nice, but if you add another VLAN, you need another port on the router. And so you start running out of ports very soon, and it can cost you more money, more hardware. So you start losing the advantage of VLANs. So router on a stick is actually where you have one port configured to have multiple VLANs. And another option, and a very fast option, is layer 3 switching using switch virtual interfaces. Now, I don't think we talk any more depth about SVIs, and we don't until CCNA 3. Anyway, so in the past, with legacy inter-VLAN routing, router interfaces were used to route between VLANs. Each VLAN was connected to a different physical router interface. Packets would arrive on the router through one interface and be routed and leave through the other. Because the router interfaces were connected to VLANs and had IP addresses from the specific VLAN, routing between VLANs worked. Large networks with a large number of VLANs require many router interfaces, and so that brings up your costs. So in this example, the router was configured with two separate physical interfaces to interact with different VLANs and perform the routing. And so we had VLANs 10 and 30, and away it went. And so one of those was 10 and one of those was 30, and away you roll. So it worked nicely, but yeah, adding another VLAN was going to cost you money. So router on a stick is basically where you have one trunk link between the switch and the router, and then on the router you actually create sub-interfaces, one for each VLAN. And so the router does the tagging like the switches do on those. And so one of the router's physical interfaces is configured as an 802.1q trunk port, so it can understand VLAN tags. And so then you create logical sub-interfaces created one per VLAN. And so on that, you need to put an IP address for each subnet that belongs to each VLAN on that. And then you, of course, you need to tell it what VLAN it belongs to with a encapsulation command. Okay, so legacy inter-VLAN preparation, and so basically it takes two ports on the router, it takes two ports on the switch, and so this port needs to be a member of the correct VLAN, so that might have been VLAN 10, and this port needs to be a member of VLAN 30, and of course you need to have those ports there as well, and they need to be addressed correctly. And so that will, as I said, it will work nicely, just expensive to get more. Configure legacy inter-VLAN routing, and so basically on the switch you create the VLANs, and then of course you assign different ports to different VLANs as we're seeing there. So port 4 is a member of VLAN 10, port 5 is a member of VLAN 30, where's that? There it is. And so that's how the router gets the traffic from each of those VLANs. And so, of course, on the router itself, you configure it as being IP address and turning it on, each one, and away you roll. That's done. Now, router on the stick configuration prep. And so basically, all you need to do, as I said, is it's an extra trunk link, but there's only one link between the switch and the router. So you save the switch port and you save the router port in this case, but of course we've actually got 3 VLANs here, so we've saved 2 there and 2 there. And so on the switch, basically you just need to create the VLANs, and on VLAN, well, port 5, I don't know why we've got 2 cables there, but anyway, port 5, we turn that into a trunk link by a switch port mode trunk. On the router, basically, we go interface G00.10, and so that creates a sub-interface of G00. And so then now that can be any number it's like, it doesn't matter, it's not important, but most people actually put that sub-interface number to be the same as the VLAN number, and so that's VLAN 10. And so encapsulation.1Q10 is actually how we tell it what VLAN this particular sub-interface belongs to, and then you give it an IP address. Then you go in and do another VLAN, so in this case, another sub-interface, sorry, so it's going to be VLAN 30, encapsulation.1Q30, IP address. And so that's created the sub-interfaces. Then you go into the physical interface and say, turn it on. And so up they all go, and you've got Inter-VLAN routing working using a trunk link. And so how do you verify it? Well, I normally do the show IP route because that's what it's going to do. And so as you can see, we've got 172.17.10 and 172.17.30, and that's on the sub-interface 00.10 and 00.30. And so that's all working nicely. I don't often bother with show VLAN, I've got to admit. So how do you verify it? So I suppose if you ping across, that would be good. If PC1 can ping PC3, that's all very nice. Trace route, of course, would also give you that information as well. But yeah, just make sure it does work. Of course, the beauty of having multiple VLANs is also, and we haven't done this topic yet, but you can actually add access control lists, and so you can actually configure who is allowed to talk to who across those, and so that, again, as we said, VLANs give extra security, and so that's one way that you can do it. Okay, so chapter summary. And so we've looked at how to create VLANs on a small to medium-sized business and how to implement that as well, and we've also looked at Inter-VLAN routing. So there's the logo, and so yeah, that's it for the week. Have a nice day.